Bearcats. This is Rational Functions A.5, and this is going to be a series of examples. So your notes can look like examples. I would kind of keep them maybe on the right side, so in case we want to add any notes to them on the left later on. You might want to make some notes about common denominators and restrictions and things like that. Okay, so this is problem number 29. There are two approaches to these problems. We could find, if we have a whole number, we're going to go ahead and put it over 1 so they all look like fractions. We could find a common denominator that would be common to all of these, and if we did, then we could multiply the tops and just solve the numerators. And that works really well in this particular case because there are no variables in the denominator. However, there's another approach I would like for you to consider that helps you a lot when we have variables. Leave this left side. This is one fraction over here. So leave this left side for a minute and let's just take a look at the right. On the right side, we have two fractions and we need to add them together with a common denominator. That common denominator, I think you can look, would be 4. This already has that common denominator. The 6 would need the 4, top and the bottom. So now our denominator is 4 and we would have 5x plus 6 times 4, which is 24. I'm going to combine those like terms and that would be 30. So really, I'm just going to erase that. I'll just mark it out. And it would be 5x plus 30. And that is now equal to 100 minus 4x over 3. If we have a fraction equal to another fraction, it should be very comfortable for you right now to think I can cross multiply and solve, and that's what we're going to do. Notice the denominators do not have any variables, so we have no restrictions. All right, so let's go ahead and cross multiply to solve. So we're going to go 4 times 100 minus 4x equals, and we're going to go 3 times 5x plus 30. All right, so we get 400 minus 16x equals 15x plus 90. Letters to the left, numbers to the right. So letters to the left, move the 15x over, be negative 15x, it's gone. Move the numbers to the right, would be a negative 400, and it's gone over here. And then we add down. So that's going to be negative 31x equals negative 310. We divide, negative and negative gives me a positive, and x equals 10. And that would be our answer. Go Bearcats. No restrictions, so we're good to go. Let's move on. All right, once again, we could write common denominators and solve the numerator, but why would we do that in this case when we have a single fraction? It's a complex fraction, but it's a single fraction equal to a fraction. We could just cross multiply and solve, and that's what we're going to do. Now, before we do that, I want to write our restrictions. Notice right here that you can't have a denominator equal to 0, so if we solve this for 0, we would find our 0 to be negative 4/5. So our x value cannot be negative 4/5. That's our restriction. And we're going to write that so in case our answer comes out, we can check for extraneous solutions. All right, so now we're going to go on and cross multiply this direction, and we would have 3 times 5x minus 4 equals, and we would go this way, we would have 2 times 5x plus 4. All right, and that would be 15x minus 12 equals 10x plus 8. Letters to the left, so minus 10x on this side, it's gone. Numbers to the right, plus the 12 on this side, so it's gone from here, and we would add down. When we add down, we get 5x equals 20, and therefore x, of course we divide by 5, would be 4. And it is just fine with our restrictions, so this is our answer. Go Bearcats. Let's keep going. All right. We have number 33 here. Again, we could make them all have a denominator of x as a common denominator, multiply the tops, and then solve only the numerator because all our denominators would be equal. And we probably will do 1 or 2 like that, but I think it's actually easier just to take each side separate. So let's take a look at this, and let's take a look at this. And actually, I think when we do that, we're going to find it all equal anyway. All right, so we're going to put 10 over 1, and we're going to put 4 over 1. The common denominator here would be an x. So this 10 would need to be multiplied by an x at the top and the bottom. So we would get 10x minus 13 equals, on this side, our denominator would also be an x. We'd multiply by an x at the top, and so we'd have 4x plus 5. Now, here's another one of those things. If you will push pause in your brain long enough and think about what you're doing, that the denominators are already the same. and we're trying to solve for x. So whatever x is, it's going to be equal in the bottom. So we really need to solve using our numerator, and that's just a little bit of a shortcut, and we'll cut back on your work a little bit. Before we do that, let's write our restrictions. Remember, our restriction is that x could not equal 0 in this case, or we would create an undefined term. So let's talk about the top. It's 10x, sorry. All right, so we have 10x minus 13 equals 4x plus 5. Letters to the left, so we'd subtract the 4x. Numbers to the right, we'd add the 13, add down. That would be 6x equals 18. Divide by 3, and x is equal to 3. Now, here's what happened when we did that. We got a 3 as our solution, and we're double checking it with our restriction. Everything is happy, so we are in good shape. Go Bearcats. Let's move on to 35. All right, here we have 35. Let's go ahead and put all our whole numbers over, make them look like fractions. Again, I'm going to take a look at the left side, which needs to be combined. The right side is just the fraction 3 over 1. Here, my common denominator would have to be z plus 2. That means I would multiply by z plus 2 here and z plus 2 at the top. So, on the left, I'm just going to keep my 3 over 1. I'm going to distribute my 2, so I would get 2z, and 2 times 2 would be plus 4, and then I still have plus 2. So I really have 3 over 1 equals 2z. 4 and 2 is 6. Oops. I have 2z plus 4 over z plus 2. All right, so we're going to cross multiply, and we're going to go 3 times z doesn't make so z. Sorry about that. Plus 2, and then we're going to go equals 1 times our 2z plus 4. So that would be 3z plus 6 equals 2z plus 4. Letters to the left, minus 2z. Numbers to the right, minus 6. And finish it over here. That's going to give us a z equals negative 2. Z equals negative 2. Oh, my goodness, did you notice my error here? The 4 plus the 2 would have been a 6. This should be a 6. I kind of ran in a room with squishing things. So this would be a 6. So this would be a 6, and this would be a 0. So we would get z equals 0. Sorry about that. Now, let's go back. We forgot our restrictions a while ago. Our restrictions were x could not equal negative 2. And so our answer is z equals 0. I think we're okay with the restrictions. So z equals 0 is our solution. Sorry about that. All right, let's move on to 37. All right, again, now this is a problem that if you will pay attention and kind of analyze your situation before you start working, you can save yourself some time. Notice these two already have a common denominator and could be combined. And notice that we actually could move the 2 to the right. So we would have a common denominator of x plus 4. And at the top we have x plus 4, so we'd have x plus 4. That's kind of interesting. And we're going to say on this side we have a 2. A 2. So we're going to put 2 over 1. And we're going to go ahead and cross multiply and solve. So 1 times x plus 4 is x plus 4 equals, we're going to go 2 times x plus 4. So x plus 4 equals 2x plus 8. Letters to the left, that would be a negative 2x. It would be a negative 4. So we'd have a negative x equals 4. So positive x equals negative 4. Now, be really careful here. Our restrictions, we forgot to write those first. We should always do that. Our restrictions would be negative 4. Don't like that. We have a dilemma. We have a dilemma. Not really. We can't be equal to, this can't be equal to 4. And so, because we can't equal 4, that there is no solution, and it's a contradiction. It's called a contradiction. There's no solution. Go Bearcats. Let's look at 39. All right. Again, take a look here. This is all one fraction on the left. and we can combine these and make them one fraction on the right. So I'm going to keep my 2. I'm going to go ahead and probably multiply these two back together, but I'm going to wait just a minute to do that. And I'm going to say equals. On this side, again, my denominator would be x minus 4 and x minus 2. This x minus 4 would need the x minus 2 at the bottom and the top. And this x minus 2 would be need the denominator to be multiplied by x minus 4 and the numerator, x minus 4. So in the top, we get 1 times x minus 2, which is x minus 2. And then we're going to distribute this 2. So that would be plus 2x, and it would be minus 8. And over here we have x minus 4 and x minus 2. All right, once again, our denominators are the same, so no matter what x is, they're going to equal each other. We want to solve based on the top. So at the top we have 2 equals, and we're going to combine like terms. We have an x and a 2x, that's 3x. Negative 2 and negative 8 is negative 10. All right, letters to the left, so I'm going to subtract the negative 3x over here. I'm going to move the 2 over here, and we have negative 3x equals negative 12. Divide by negative 3, and x is equal to 4. Now, again, I forgot to write the restrictions. You've always got to go back and do that. Our restrictions were x could not equal 4 or 2. 4 or 2. So 4 would make a denominator undefined, so this is an extraneous solution. So in this case, there would be no real solution. All right, go Bearcats. Let's look at 41. Okay, again, if you're paying attention, you're going to get this right. Look at the left side first. We want to combine those two fractions. Well, then the denominators would have to be x minus 3 and x plus 3. Ah, well, look at that. This one then would need the x plus 3. That's x plus 3. And this would be the x minus 3, and this would be x minus 3. So at the top, we'd have x plus 3, and this is a positive, so plus x minus 3. And if you're paying attention, the denominator is a difference of squares. Okay, so when you FOIL that back together, you're going to get x squared minus 9. Ah, and you already have on this side x squared minus 9. So our denominators are the same. We don't really need to worry about that. We will be solving the top. Well, look at when we combine the top. We have 2 x's. Our 3's cancel, so we have 2x equals 10, and therefore x equals 5. What looked like a complicated problem really wasn't. Our restrictions, by the way, were x cannot equal 3 and negative 3. So we are in happy shape here, so this for sure is our solution. Go Bearcats. All right, let's move on. All right, let's take a look at 171, problem 171. Again, I'm going to look at the right and make an adjustment here. I'm going to put this just over 1. So I have x over 1 equals. My common denominator on the right side would be 2 times x, or 2x. That means this would need the 2 at the top and the bottom. This would need the x at the top and the bottom. So at the top, I'm going to get 6 plus 1x, or 6 plus x. Now I have two fractions. I go back to my whole cross multiplying. Before I do want to talk about restrictions. X could not equal 0 in this case. All right, let's cross multiply. So we have x times 2x equals 1 times 6 plus x. So 2x squared, equals 6 plus x. That's a quadratic, so we're going to have to solve using quadratic methods. So I'm going to move the x over. I'm going to get 2x squared minus x minus 6 equals 0. Let's see if we can slip and divide this problem. So we're going to take the 2 over here with the 6, and we get x squared minus x minus 12. Go ahead and factor x and x. 3 and 4. That'd be a negative 4 and a positive 3. And then we need to slide or divide our 2 back in. So divide by 2, divide by 2. And in this case, our x values then would be x. It would be equal to negative 3/2. And x would be equal to, since this is negative 2, be positive 2. And I believe that these check out with your restrictions, so those would be your final answer. Oh, Miss Thorne just made an error. Look, this 3 and 4 is, oh no, that's right. Miss Thorne did not make an error. But, yeah, no, we're good. All right, let's move on. All right, let's take a look at this one. Again, we're going to work on, this time, the left side to try to make a combined denominator, which would be x times x plus 1. This time, this side needs the x plus 1, top and bottom. You can stop writing at the bottom after a while. You'll get used to that. And this side is just going to need the x. So probably starting with the next problem, I'll stop doing that. So at the top, we'll have 1 times x plus 1, or x plus 1. Be really careful. We have minus 1x, so minus x equals 3 over 1. All right, now this time they're not the same. We're going to cross multiply. At the top, though, I can combine like terms. And I really have 1 over, and I'm going to go ahead and distribute. This would be x squared plus x equals 3 over 1. Look at this. This is kind of an interesting problem. So 1 times 1 is 1. And we're going to have 3 times x squared plus x, equals 1 times 1. All right, so we have 3x squared plus 3x equals 1. Move that over. 3x squared plus 3x minus 1 equals 0. All right, so let's take a look at this. I don't think I can. That would be a 3. I'm not going to multiply to get 3. Let's take a look at what happens with 173. And let's work on quadratic formula. So our quadratic formula, of course, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, our a value is 3, our b value is 3, and our c value is a negative 1. So let's substitute in. So it would be a negative 3 plus or minus the square root of 3 squared is 9 minus 4 times a times c all over 2 times a. So negative 3 plus or minus the square root of some number all over 6. Let's think about this number. Since this is going to be 9, then you've got to think this is a negative 4 times a 3 times a negative 1. That's going to make it positive. Positive 4 times 3 is 12, so plus 12. So 12 and 9 is going to give us a 21. 21. And there is your answer. We can't reduce any of that, so there is your answer. Go Bearcats. Now, I guess you could write this as negative 3 over 6 plus or minus 1/6 square roots of 21. And you could reduce this to negative 1/2 plus or minus 1/6 square roots of 21. I would also accept that. All right, let's look at 75. Okay. I was recording. I'm sorry. I have to finish this.
That's okay. That's okay. You'd asked me about Teams things.
I know.
So go ahead. I'm sorry.
I didn't know what that. Okay. I hope I did that one. If I didn't record 175, there it is. So let's move on to 177. All right. 177, I lost 1, and we get x over x squared minus 4 plus 1 over x plus 2 equals 3. All right, again, we're going to put the 3 over 1, and we're going to look at what is contained in this denominator. If I break this denominator out, this is x plus 2 and x minus 2. All right, so let's look at this side of our fraction, or our equation, and that is going to become our common denominator, x plus 2, x minus 2. This already has that, so the x just stays. This x plus 2 needs an x minus 2 at the top and the bottom. So 1 times x minus 2, and this is plus, would be just plus x minus 2. All right, so cleaning this up a little bit, we have 2x minus 2. We could go ahead and multiply those back together, which would be x squared minus 4. And now that equals 3 over 1. And cross multiplying now becomes pretty simple. So let's do that. So we're going to go 3 times x squared minus 4 equals 1 times 2x minus 2. 3x squared minus 12 equals 2x minus 2. Let's combine like terms and see what we get on our quadratic. So we have 3x squared, move the 2x over, negative 2x, move the 2 over to be positive, so minus 10 equals 0. And now we're going to have to go through, I believe, the quadratic formula on this one. So again, negative b plus or minus square root b squared minus 4ac all over 2a. And in this case, a is 3, b is negative 2, and c is negative 10. All right, let's plug them in. So we have negative negative 2, so we have a 2 plus or minus the square root of negative 2 squared would be negative 2, and negative 2 would be positive 4, minus 4 times a times c all over 2 times a. Remember, in the quadratic formula, if you have one of the values negative over here because of the subtraction, then that's going to end up being a positive. So we're going to write 2 plus or minus the square root of something. Remember, that value underneath is called the discriminant. That value is called the discriminant, and so this would be over 6. Let's see what the discriminant is. This would be a 4, and then negative 4 times negative 10 is positive 40, and positive 40 times 3 would be 120, so plus 120. And so underneath we're going to find 124. And we're going to simplify our radical. Here's what I'm going to have you do. Tomorrow when you come to class, I will give you a slip of paper, or you can ask me for one, and I'm going to have you make sure you've worked this problem and you simplified this entire radical. All right, have a great night. Good night, Bearcats. 1, 2, 3.
Go Bearcats!